Hello, everybody. Welcome to the Mindplex podcast. We are here today for a special edition of the Mindplex podcast where we are in Singapore at the SuperAI conference. And today we are talking to Jansen Teng, founder of Virtual's Protocol. They are building a decentralized protocol for creating co-owned, human-curated, plug-and-play gaming AIs. Welcome, Jansen.
Hello,
Hi.
hello. Glad to meet you all.
So tell us how Virtual's Protocol will be the backbone of decentralized AI for gaming.
Yes. So I think that's the vision, right? I think the idea is like if we can host a library of 100,000, a million different AI agents that are used for use cases in gaming and entertainment beyond. That's the idea. But I think what fundamentally drives this is two parts to it. One is that we have a incentive layer that rewards people who come and contribute different parts to this intelligence. An example of what this AI agent can be, it's like imagine in gaming, John Wick could be a NPC character, right? Or you can use John Wick in some form of short animation or a skit or whatnot, right? So imagine if you have this John Wick AI agent, it has the ability to talk, to text, and to also move in a three-dimensional space. So for that to happen, you will need people to be able to contribute to these three different aspects. So to like the texting or the cognitive core, you have your people who contribute the standard LLMs, right? Like it could be a Llama model, it could be a fine-tuned Llama model, or even it can API it out to like a ChatGPT equivalence, right? But what gets more interesting is when you start going down the other facets of this John Wick agent, his voice. His voice now it starts becoming harder to work, right? You need what we call a text-to-speech AI model. And for that to then work, you need someone who would go through all the John Wick movies, slowly convert all these videos into some form of trainable voice data. So you label the voice data and then you upload it to the platform, right? And then you have people who then go and train the animation rig, right? Like because John Wick walks in a certain way, there's a certain slouch, a certain kind of action stance that he tend to have. And all this has to be captured in a labeled motion capture data. So there's different pieces of information that has to come from different groups of people to actually create a single, highly curated John Wick AI agent. And for that to then happen, we have this incentive layer that ties all of this together, i.e. if we call it a proof of intelligence concept, where depending on the level of intelligence you're contributing to this John Wick agent, you get a piece of ownership or a percentage of ownership of this John Wick. So in the future, when this John Wick agent is monetized in a game, monetized in a movie, or monetized in any kind of interaction, you as a co-owner of this agent, you get a piece of that revenue. So that's the fundamental underlying idea behind what powers Virtual Protocol. And you do this for 1,000, 100,000 different agents, and then suddenly you have this world of AI agents that could either live in their own simulation or you can use them for any kind of entertainment use cases. Yep.
Right. Well, that's the exciting part to me is actually to have a decentralized. I mean, we've been wanting avatars that could plug into one world and that we can export and put into another world forever, right? As long as we've been in VR. So now when you talk about this John Wick example, again, I'm trying to picture it for our less technical viewers. The John Wick character that you're talking about creating is essentially kind of like an NPC in a game, like an NPC on steroids or something, right?
Correct. It's what we call like next-gen NPCs, right? Because today,
okay, great.
Yeah, and I think the beauty about these AI agents is that I'm not sure how much of your audience are gamers, but gamers will be able to resonate with
a lot of them. So
okay, that's great.
Yeah.
Because if you think about it today, right, like if I take a gaming use case as one vertical of an example, today NPCs are very static. Like if I play Elden Ring, I have three choices. The guy will say like, okay, there's a knife on the table, right? You take the knife, you stab me, you take the knife, you throw it away, you take a knife, I don't know, you put it in your pocket. And then what game developers do is they spend years to plot out the scenarios and how this affects other scenarios, right? It's
Right.
years of scripting
Decision
and
trees.
programming. Decision trees, correct.
Yes.
But the beauty about what AI agents can do today is because what we've created with this, we have a functional capability that allows our agents to actually do two things in the game. One, it recognizes in environmental context, i.e., I recognize that there's a knife on this table. I recognize that there's this another character I'm speaking to. It can be a gamer, it can be another NPC. And then it has an objective function in his mind. Like, let's say my goal as an NPC is to build the largest rocket in this world. And he would then take action in the gaming space autonomously to achieve his objective. So that's an example, right? So what that then allows you to do is you create this thing what we call an emergent gameplay. Because now as a gamer, if I interact with this NPC, right, he has his own objective, doing his own stuff, planning his own life. But when I interact with him, instead of only having three selections of picking a knife, putting a knife in a pocket, or stabbing him with a knife, I can take my slipper and slap him in the face. Now, if I take a slipper and slap him in the face, what happens then, right? Like, it's a very...
So you're making something up spontaneous, though,
Correct.
Is the point. Something that hasn't been thought out already with the reaction.
Exactly right.
Okay.
So the response now becomes generative, right? Now, as this John Wick agent, now I get slapped by a sleeper. What do I do, right? And that's where the LMs come in, right? You say like, okay, the next most rational course of action is to take a sleeper and slap him back. What if, right? If that's the case, right? So now when that happens, the game changes, right? Okay, now suddenly this sleeper becomes, I don't know, some golden sleeper that is some form of value in the entire game space. It impacts missions, quests, whatever it might be, right? And basically what it means is that every gamer's experience is different. So my experience is different from yours, it's different from anyone else that's playing the game, right? And that's where the emergent gameplay hypothesis or idea is hopefully to be realized from this kind of fundamental technology.
It'd be one of those things when there's a spontaneous thing that the agent did to one person, and then everybody else will go to that place hitting them, trying to get hit.
Yeah, or they will try different stuff, right? Yeah.
This is like, see, I'm an old timer, so I was in Second Life a million years ago.
Okay, yeah.
And spontaneous stuff in Second Life was super exciting. Like, you didn't get it very often, right?
Yeah.
And so when it happened, everybody just lost their mind, how cool it was. And then you were trying to recreate whatever the spontaneous thing was. But of course, it was just a fluke thing to begin with. So you could never really people would try to make animations doing the thing that happened.
Yep.
And stuff like that, right? And they would even make you would have Second Life sites that were just an animation, basically. It would be like 10 minutes of a concert or something that they had, and you could come in and watch it and leave or whatever, right? And so this is like a really big deal, spontaneous behavior. So that
and I think if I
can
touch on this spontaneity element, right? Another key use case that we figured out that was a very low-hanging fruit for the near term is that imagine AI influencers, right? So today, I think there's a whole era of virtual influencers coming out. It started off with VTubers where it's actually a human behind, and then they put on a layer of this live 2D kind of character that, it looks like a cartoon, looks like an animation, like an anime. So that became an industry, very big in Asia Pacific. And then right now, what's happening is people are building AI influencers. So, but the problem about AI influencers today is that a lot of the content are pre-recorded, right? Like, it takes time to generate an influencer's reaction and motion and content. But the beauty about, again, another functionality that we've managed to develop on the platform to expand the use cases of our AI agents is what we call a large animation model, i.e., you can take any form of text, any form of audio, you plug it into this AI, he can generate an action space. So the three-dimensional rig that any kind of CGI guy uses or any kind of gaming guy uses in any kind of 3D space, and AI can control that rig, meaning that you can actually say, hey, do a chicken dance, and the rig will start dancing like a chicken. You ask him to do a squat, the rig will squat. So meaning that the AI can control the three-dimensional motion of a character.
So it has some kind of library that it's pulling from to have
it's not
that.
Library.
How does it know how to move? Like a chicken.
It's trained by an AI. So it's an AI large model behind. So basically what you feed in information, you feed in motion capture information and you label that motion capture data. It's like a loss function towards motion.
Generating it in real time?
It's generating in real time.
It's saying, okay, this is what a chicken looks like. This is the chicken dance they're talking about.
Correct.
Here's my
so normally
thing.
what you do from a training data set is you do a lot of different motions, right? Like, okay, this is a squat motion. You label it as a squat. you do like some form of, this is a dance song, you put an audio in, and then you generate a
Right,
K-pop dance
but
out
do
of
you
it.
have to do it ahead of time, or are you talking about the AI doing it on the fly?
The
That's
AI
what
will
I'm.
do on the fly because you've already
Wow.
trained the AI with this large amount of data set, of motion capture data set. So what we've managed to do is we managed to do it, but the inference time is still a bit long. I think it takes like 12 seconds to generate an inference.
Oh,
So
12 seconds.
yeah, I mean, but for us, we're thinking from a
Yeah, it's a
consumer
long
angle,
time.
you want to
Yeah,
bring it down
yeah.
to around a 3-4 second layer for it to feel like, okay, it's live, right? So,
Uh-huh.
but right now it's doable. Like you can actually say like, I plug in I don't know, a Macarena song, and then the AI will do a Macarena dance. So that one is already doable. But the beauty about what I'm trying to explain here is that
Yeah, yeah.
now your influencers can actually do live performances. And if you, let's say on TikTok, right, I tip you $100 and I want you to, I don't know, do this kind of K-pop dance for me, right? Like, you know, this whole thing happening on TikTok and Bigo and all these are live interaction influences. Now that could happen. Previously, it cannot happen, right? But this can also translate into this gaming environment. Because when I mentioned to you, I slapped this John Wick NPC. How does he then slap me back, right? You can only do that if your motion is actually generated by an AI. Because the action space is way larger than what a standard library can actually afford you. Because a slapping you with a shoe motion is not probably the most common motion that you will see in like a animation library. Okay, maybe slapping is but maybe I don't know, something like a karate jiu-jitsu kick towards you or some shit like that, right? So
Right.
point is, these animation models allow for that kind of action space to increase and to generate that in a spontaneous environment. So these two core technology, it's something that we've been bringing to the space, and we realized it can apply to animation, TV, even companion chats, like, you know, have an AR girlfriend, that kind of stuff, right? It all can exist because of these agents that exist on the platform.
And you could take your agent, once you've worked so hard creating an agent for one platform, because of the way that you have people developing it, in theory anyway,
Correct.
you can plug it
Correct.
into other
Yes,
platforms,
and that's one
right?
of the key major proposition of the protocol, because the idea behind this library of agents is that anyone can come to this library and read this library. So it becomes a plug and play solution for anyone, right? Any games want to API into this John Wick NPC, they can do it. If we create our own IP of a certain NPC or IP of our own influencer, a game can API into that influencer, a TikTok entertainment platform can API into that influencer, a TV or animation series can API into that influencer as well. So it becomes a very composable agent that can be used anywhere.
So wait a minute. You're talking about when you create an agent on your platform, there is an API available to let you kind of sell the usage of it to other people if you
Correct.
want.
That's
Oh,
exactly the key use case of it. Because the
wow.
idea is that by spending so much resources and time in creating and curating a very, very highly used, very high quality agent, ideally you want it to be used in multiple areas so you increase your revenue surface area. So that's the idea behind it. So it makes it
That's
very easy
great.
for it also makes it easy for any founders, because one of the key reasons why we started Virtuals was that we were trying to create some consumer-facing AI applications. And then we realized the process is not easy. There are a lot of models out there, be it open source or even like closed source like GPT, right? But to tune it towards a use case, like let's say an AI girlfriend, right? You need to fine-tune the models so they're a bit more role-playing. There's a lot of things to happen in between to bring them to a level that the end consumer actually wants to interact with, especially in this whole entertainment and gaming front. And that's the reason why we started Virtuals. So we wanted to solve that problem and to allow any kind of founder, right? Hey, look, you have this free AI CTO for you. You don't have to care about, it's like a Shopify, right? I don't have to care about how to build the fundamentals of a website. I can just come to this platform. If I want to use an AI agent, let me just API in. Now I have a fully functional AI agent that can talk, can speak, can move, and even with virtual assets that you can actually utilize. And that's the goal behind it.
Nice, nice. Well,
And,
that's
and to
always
add a
been the
caveat, sorry,
dream.
I'm not going to be long here, but
Well,
what
it's
we've also
okay.
done, we've realized that IP holders, so I mentioned a lot of John Wick, right? The question is then, would John Wick, would Keanu Reeves actually like it, right? Like you're using his form for these different use cases.
It would
What
have
we've
to be
done was we've
licensed
actually,
in this
correct.
case.
What we've done was because effectively what we are building is a platform that allows for the co-ownership of different agents, right? Different contributors will own different percentage of it. We've ring-fenced a percentage ownership of it for Keanu Reeves himself. So in the future, the idea is that we will then have a team that goes out there and tell Keanu Reeves, Taylor Swift, and all these different big IP brands, animes in Genshin Impact and whatnot, right? To get them on board and say like, hey, look, this is the proper way of how we think AI agents should be deployed if they're using IPs. There is a ring-fence royalty for you guys, and here's this bucket for you and for any future revenue that's going to be generated. So I think that's the idea behind also getting the IP owners as co-owners of these agents. Yeah.
Yeah, and it could be a boon. It seems like for the creators that work on. It was always one of the most heartbreaking decisions when I was making an avatar. Was sort of like it was only going to be for that world, right? How
Yeah.
much time did I want to spend on my VR chat avatar, right? That I can only use there or whatever. So moving it around is the dream. The dream. Tell us how your autonomous smart contracts work.
Yeah. So I think that's where that smart contract layer effectively ties everything together. So what I've mentioned was all these different contributors that contribute, right? So how are they then contributing? For us, what's very important is to prove an ownership of a person. So if I contribute this X amount of data set of, let's say, John Wick's voices, theoretically, I should be the owner of that clean data set because I spent hours to actually clean it and to refine it so it's a trainable data set. When I upload it to the platform, what happens is this bunch of smart contracts would put all this information on chain. They will mint me an ownership, we call it ownership NFT. Right? It's just this object that I will throw into your wallet that proves that you are the owner of that data set. And this bunch of smart contracts will then notify this group of validators or curators who will then assess whether this information or this data set is worthy to be accepted into this John Wick agent. Because you can actually upload a Taylor Swift voice into this John Wick agent. And then when these validators do a A/B testing, they'll be like, A, which is closer to John Wick, A or B, right? This one doesn't sound like John Wick at all, it sounds like female. So they'll discard the data set. So then this contributor will not get a single share of ownership, right? But let's say a proper John Wick contributor comes in, he contributes proper information, this group of validators through the smart contracts vote that, yes, this increases the intelligence of John Wick, we'll assign you an impact score. And the impact score is effectively your ownership score. So all these are then facilitated by smart contracts. So it's a bunch of programs that it's not a human behind it telling that, okay, yes and no, it's just a bunch of code that is just running at the background saying that, yep, you've contributed this. Now this group of people that are voting, their vote is this, you get accepted or not. If it gets accepted, it upgrades the entire John Wick to V2. It upgrades it to V3, upgrades it to V4 autonomously. So that's the backbone of the system.
What's version 2? Oh, you just mean when it's used as it gets
Yeah,
better
when,
and better,
when
it
it gets
upgrades.
upgraded, right? Because if I upload
Yeah.
a better version of a John Wick sound model, it gets trained, it means it improves the John Wick, so John Wick goes to a version upgrade. There's a version
Nice.
2, a version
Okay,
3, a version 4.
and every time that happens, this is the whole point of the smart contract thing, is that every time it gets used, it's just automatically
Dispersing the
generated.
revenue as well. Correct.
So it could add up. It could
Yes.
actually be a job. I mean, for someone who's good
Correct.
at
And
doing
in fact, I
this
think
kind of
what
thing.
we've seen on our platform so far, so because we went live about 2 months ago, I think the average earning right now of a contributor is around $300 to $1,000 a month, which is honestly decent. I would think it's a decent job. I mean, and these guys are not spending like the whole month actually working on it, right? It's like contributing maybe 1 or 2 data sets, fine-tuning a model a bit, and that's the current payout that we are seeing on the platform. I mean, it might fluctuate based on demand, based on revenue and whatnot, but this is what's happening today. So yeah, honestly, it can create a new gig economy of workers, right? Who just spends their time to generate data sets, upload information onto the chain.
Cool. So let's see. The last thing I wanted to ask you about was the different kinds of digital twins that you talked about on your website. The user mirror, function specific, and character mirror.
Yeah.
And just tell
So
us
just
a little
now
bit about those.
I've mentioned like the John Wick, right? So a John Wick
Yes.
is what we call an IP mirror, right? It
Okay.
takes on an existing IP or a famous IP, and then you create a mirror of it, or
Okay.
AI of it, right? So that's the first type. The second type I've mentioned about, this whole ability to enter a game and to have in-game contextual awareness and whatnot. That whole architecture is also actually an AI agent. It's a bunch of, there's an objective function, there's a bunch of code and a bunch of calls into different cognitive LLMs to help it shape its decision trees. that itself is also a agent that we call a gaming agent. So that's a functional agent on the platform, or functional virtual on the platform. Or another example of another functional virtual is like we have a company that it's a companion chat that is actually APIing into our platform. But what he needs is the ability to convert all the responses from all these different AIs or agents or IPs into something more role-playing that has a bit more environmental context. I.e., the response that they want is when I ask you a question like, hey, how are you? They don't want a response of just like, fine, thank you, right? They want, fine, thank you, and the girl smiles
Blah,
and
blah,
she
blah,
waves her
blah,
hand
blah.
at you, right? There's an additional
Yeah.
context around that, right? So that extra bit is a function that this guy needs. So that's where another functional agent gets minted onto the chain. So then what happens is this group of applications who want to create this virtual companion chat will first API into this functional character, and then the functional virtual would then call from the different character agents to get their responses. So it's like a layered cake, if you think about it, right? A different layer of interaction. And then the third one is basically a user mirror. Is effectively if you yourself want to upload more private information about yourself, you want to create an AI about yourself, we've created a private network for you, i.e. you can upload more personal information and it's not public, it's encrypted, but you can then create an AI version of yourself. So that's the user mirror, because it mirrors the user. And this could be something that you either send to a friend to talk to, or you can create as a player too in a game, right? It's my own companion. I have two of myself playing a certain game. It could be that kind of future.
Play against yourself.
Yeah. But another key thing, this one is a very interesting part, right? The user mirror, because in the China region, there's a massive industry that's been growing in the past few months of how families wanted to revive loved ones. They were just wanted the extra like 1 minute of a video of their loved one talking to them, or it being in a video just playing around. And you can see it on Xiaohongshu. Xiaohongshu is like a TikTok app in China, equivalent, and they're selling it for about $50 to $150 a piece. And there's insane demand in it in China. You guys should go and check it out. It's very interesting.
What is it now? It's a 3D representation of a video that you give them or something that you go in and hang out with?
It's a mimic of a loved one. So like it could be a loved one that could be passed away.
It's a digital twin. It's a digital twin of a loved one.
Like talk like your loved one, sounds like your loved one, looks like your loved one. And it's happening already today rapidly in China. And it's quite an insane industry.
How good can it be from people have been doing this for years, right?
Correct.
In different ways.
So I think what people are doing right now, it's
from photographs and letters and
yes, correct. It might not be a perfect replica, but I think today the market has this pain enough to want to desire this, that even if it's a 70% solution, they are willing to have it to pay for it as a product. So just check it out. It's very interesting. Something that I think your audience should just, if you guys are interested in this consumer use cases front, right, of agents, this is another key use case that's coming out of the East.
Yeah, it sounds fascinating. And this is really interesting, just to, because you mentioned that you were based out of Malaysia. And this is one of the reasons why we came to the conference, was to try to get a more international
you got to see what's happening on this side of the hemisphere.
Yeah. So we're finding out about all sorts of different apps and things that we had just never heard about before. We're in our little bubble here in the United States. We really are, to a certain extent. And so it was really great talking to you. I'm really excited about, the Virtuals protocol. And I literally am ready to tell my friends, me and my VR friends and gaming friends, we've literally been waiting for a true decentralized avatar system for a real metaverse. Yep. And the metaverse is decentralized, right? Not whose metaverse, but the real metaverse that's been around since the 70s or whatever is decentralized. And so it's exactly what we've been waiting for. And I can't wait to look into it more. And thank you so much for coming on the show.
Well, it's my pleasure. It's great.
All right. Thanks a lot. Bye-bye.
Right.
See you later, everybody. Sweet dreams.